Okay, I think it's time to start. So thank you everyone for joining and welcome to our session. People are still signing up, but some housekeeping rules. Please keep your microphones muted during our session. If you have any questions, just put them in the chat. We will make sure to address them. Keep your cameras off as well, and kindly note that the session will be recorded and it will be available afterwards in agROBOfood YouTube channel. So once more, thank you for joining, and I'm giving the floor to our moderator, Eric Pekriet.
Thank you very much, Dimitra. Very much welcome to all of you. Thank you that you are all plugged in here at the agROBOfood week about visioning the future of agri-food robotics. That's what the network would like to build on. So I think we have a very nice program the coming days. If you did not investigate the full program, it's on the website. Please have a look there. What are we going to do now? It's the opening session of this agROBOfood week, and we would like to share some new insights about the agenda on agri-food robotics. So what is very important? We are doing it via two introductional presentations. The first one will be of Jerome Bandry. He is Secretary General of SEMA, and he will present the plan of SEMA. They made a plan for 2030, which is very interesting, I think, also contributes very much to our thoughts, and we thought it would be very good to have him in this presentation. Second one is Sławomir Sander. Sławomir is chair of the EU Robotics Topic Group Agriculture, where they built on robotics for agriculture. He made, together with a team, I was one of them, a report, an agenda, a strategic research agenda for the robotics in agri-food. So a little bit broader than only agriculture, what SEMA is doing. So it's also food, and it's more targeted on the robotics. I don't see the notes, so sorry. Agri-food was a note. Future that we are already. No, sorry, I cannot read it. Slavko, can you just tell what is on your notes?
Yes, sorry. I gotta say, agROBOfood is definitely the future we need already now, and definitely the synergy with among all of us is required. Absolutely.
Yeah.
That's all what I have to say.
Oh, good. Yeah.
Sorry, won't interrupt more.
Yeah, no, so fine. So good. So basically, this was my introduction. My personal role within agROBOfood, that is, I'm the network coordinator of agROBOfood, and I will, in my daily work, I'm also working as a program manager on agri-food robotics at Wageningen University and Research. After the two presentations, we will have a panel discussion with people from out of Europe, from the EU, DG Connect, Juha Heikkilä, from EU Robotics Topic Group Agriculture, Sławomir Sander, Thilo Steckel from the equipment industry. He is from Klaas. Kees Lokkost, which is our who is our coordinator of the agROBOfood project. We have Reinhardt Schmidt. He is from the EU robotics umbrella, so to say. He is a director there, and can also make the connection between other robotic domains. And we have Ivo Hustens. He is the technical manager of SEMA. So that's, and we will use Slido when we are right at the panel. Not now, but keep this in mind. I would like to give the floor now to Jerome. Jerome, please.
Thank you, Eric. Thank you, and good morning, everybody. It's great that we can participate to this event. It's a pity that we're still remote, but yeah, that's the new normal, I'm afraid. and hopefully we can meet in person soon. Let me share my screen just to make sure everybody sees my slides. Is it okay?
Yeah.
Okay, perfect. So thanks again for the invitation, and indeed I'll try to put things a little bit into perspective as long as our views are concerned as SEMA. So as you know, we are the European association representing the European agricultural machinery industry. We're made of 10 national members, represent a sector that has a turnover of about 40 billion euros every year. For a European market, around 26, 28 billion euros. So a lot of what we do in Europe is actually exported to the rest of the world. And with the distribution chain, we represent 300,000 jobs, industry jobs, half of them being directly on the manufacturing. And we're really here to advance agricultural machinery and solutions for sustainable farming, bringing our expertise and helping to make up the legislation that will be applicable for the benefit of the sustainable farming through our equipment. And the stuff we do as manufacturers runs really from all the different stages of agriculture, from seeding up to harvesting, and don't forget also all the livestock management technologies. So that's us in a nutshell. The challenges we face, and they are known. It's always the same paradigm that we have to play with. We know that we're going to have more and more people to feed. That's clear for everybody. We're going to reach almost 10 billion people by 2050. But the reality is also that we have less and less people that want to engage into farming. If you look at the numbers coming from Europe, it's a third of the farm managers that are over 65. There's nothing wrong with that, but it tells also that this is maybe not the most attractive sector for younger people. At the same time, we also have more and more pressure on the toolbox and what's in the toolbox. There are some tools that are being removed, and I'm not here to say it's good or it's wrong. It's just a fact that the number of elements that people can have at their to help them and to support them in growing stuff is being challenged. We also have to acknowledge that there are different types of farming. And here again, we're not here to say that one is better than the other and so on. We can definitely see an evolution more towards conservation agriculture than maybe other ways of growing plants. But it's also clear there's no silver bullet. There's not one solution, one way of farming that we can copy paste around all our area and find the solution. And last but not least, we only have one Earth. So if we take all that into consideration, put it in the back, mix it up, the only certainty we have as an industry is that without mechanization and without technology, it's not going to work. Mechanization, digitalization, technology is going to be part of any solution that we want to put forward. And it's true if we look at the evolution of the machinery. We went away from the pure, universal machine, workhorse on the farm from the 50s to bigger, faster, wider, to smarter and connected, and maybe tomorrow completely autonomous and driven by artificial intelligence. I mean, that's the trend. But let's not forget the big challenges out there. So as you said, Eric, indeed, we've been putting some thinking together within the industry and coming up with this Agri-Tech 2030 plan. And my goal now is not to drive you for all of this because it'll be a little bit too much. But just to give you an idea, we have three basic legs in this plan. The first one is to try to maximize our contribution to a highly productive, competitive, and sustainable farming with, of course, high safety standard. So behind this, you have all the legislation applicable to us as an industry. The second one is to try to bring European farming through our technologies and solutions at the forefront of digital and precision agriculture, because this is clearly the future. And the last one is more the global side of things, is how do we stay competitive as an industry, and how do we strengthen this industrial and technological leadership that we have in advanced farm machinery. So I'm not going to go through all this, but just for you to get a sense, I've put I highlighted all the stuff that is related in, and you're seeing the whole strategy here. So all the stuff that is related to digitalization and robotization, so that you get an idea of how important it is for us. And if I look at the competitiveness of the industry, the legislation that is applicable for us, very briefly, we have to make sure that the link between our machinery and the act of farming is fully understood. As I tried to explain in the context slide, without agricultural machinery, it will be very difficult to do farming. We have also to make sure that there's a holistic approach to the different policies. The policies, the industrial policies, the digital policy, the environmental policy, and the agricultural policy, they need to be interlinked. They need to be acting together. And then, still on this chapter, of course, legislation must be proportionate and appropriate. If we copy paste too quickly stuff from other parts and we try to apply it to machinery, or if we go really over the edge on trying to legislate too much some stuff without having a real impact assessment on the impact, we're going to lose sight of the competitiveness. The second leg of our strategy, as you will remember, will be to bring farming to the forefront of digital and precision agriculture. And here, of course, it's no surprise that everything we have in our strategy is linked to digital and robotization. And just to pick a few, if we don't try to bridge the gap that we have between what is available and the uptake of those technologies on the ground, it's going to be very difficult to get there. And to do that, we're going to have to make sure our new CAP, the Common Agricultural Policy, is supportive of those technologies and measures that allow to invest in greener equipment, digital and precision technologies, all the things that will enable these technologies to deliver. We're going to have to make sure that we keep the research funding at high levels, or that we increase it, in order to provide those large-scale pilots and digital test beds that will enable farmers to understand the value added of the technologies and what can be gained. Let's not forget improving the digital skills and also leveraging the knowledge available through the advisors, and making sure that we have enough investment in infrastructure, especially in rural areas, because if we can't connect, then it's going to be very difficult to have digital technology. So that's the second leg of our strategy. And the third one, which is more the international competitiveness, very briefly here, we also need to have policies that encourage the leadership that the industry has and continues to have. And here again, we have research funding in the most promising technology areas, such as automation, robotization, digital connectivity, and artificial intelligence. We have supporting the machine developments now through the eco schemes and others that will promote process efficiency and overall CO2 reductions, and raising the awareness of the agricultural and industrial sectors in order to make sure we attract the best brains, but also in order to make sure that people don't get scared off maybe by some of the new digital farming possibilities that we have. So I don't want to overburden the audience with our own strategy, but I just wanted people to have an idea of how important digitalization and robotization are in the thinking of industry. But we still have two challenges ahead of us. The first one is to make sure that all the technologies we develop are available to all farms. It's not only the big exploitations, not only the big farms out there that should be benefiting from the big advances allowed by guidance systems, by precision farming, and through variable rate applications in nutrient sensing. The livestock management now is seeing a lot of developments, has seen a lot of developments. Even heat sensing on cows now is becoming something almost mainstream, but it's still a very small percentage of take-up. And the farm management information services, that is really key. So that's the first thing. How do we make sure that the uptake and the access is for all farms of all sizes, not just the big ones. And then the second one, and we've been working on this for many years now, is making sure that there's trust on the data usage. If we still cannot trust all the different parts of the chain on whose data is this, what can it be used for, do we have this captured in a contractual arrangement that puts some clarity, we're not going to leverage the benefits of this agriculture of data that we have in front of us, and precision farming and further digitalization and robotization. And as you know, this is why the industry has been engaged for many years now on this code of conduct, which is not perfect, but it's providing guidelines on what to do, what not to do, and who owns what and who is who. It's a living document, so it's seeing some updates being put to it on a regular basis, and I would really encourage you to have a look into this. So that's the first one, and we come from Europe, so if we have one thing to say to our institutions now, how can we make this up? We like to think of EU as enable the uptake. You know, we've got those smart and precision agricultural technologies. We have the digitalization on. How do we make sure that we get towards more sustainable farming by enabling this uptake? Can robots help? Yes. Definitely. I mean, that's what the question of for our 3 days. And I hope we can have a little video playing, which is coming from our directly from our last summit, just a couple of weeks, months now ago, and which tried to capture a little bit in 3 or 4 minutes how robots can help. So if you can run the presentation, I will stop sharing my screen, and if the sound runs, that's great.
With a world population growing to 9.9 billion in 2050, we will need high yields to produce enough food while protecting the environment and preserving the biodiversity. Many man-hours of hard, precise and skilled work will be required. Can robotics and autonomous machines in agriculture help? Robotics in farming can increase productivity and competitiveness by performing labor-intensive and repetitive tasks, free up time for decision and management thanks to fully automated vehicle functions, better protect the environment and biodiversity with the continuous monitoring of plants and animals, and a targeted application of inputs. Can we imagine future agriculture fully automated? We are still far from having fully automated farms everywhere, but robots are increasingly used to help farmers and are attractive for new generations. New ag robot manufacturers are emerging, and there is a real interest from the whole machinery industry to invest and experiment new concepts. How can ag robots really take off? We need common technical rules to ensure appropriate health and safety levels for agricultural applications in the field and road use, clarify the responsibilities of manufacturers, users and bystanders, and ensure a common approach for all agricultural equipment. More than ever, robotics have a bright future as part of the agriculture of data, further leveraging artificial intelligence and other innovative technologies. We are SEMA, and we help prepare the digital future of sustainable farming.
So well, I hope this helps capture a little bit the mood and the approach of the industry when it comes to digitalization and agriculture. And Eric, you had asked us in advance, you know, if we had to put it in one sentence. I would say, for us, the future is bright if we are able to get the conditions right. So that'd be my contribution today.
Okay, thank you very much, Jérôme. I have also a small question from a European position. What is your biggest fear if you look to the outside world, and what is your biggest what is the biggest diamond we have?
Well, I hope it's a low-hanging fruit more than a diamond, but yeah, we can really hear continue to leverage the leadership that our industry, our European industry, has on this. Remember the original number I showed you. It's an industry of about 40 billion euros every year for a market of only 26, 28 billion euros. So there's a lot of expertise and know-how in this industry. We've got a lot of great brains looking into this. I mean, that's frankly one of the reasons why I joined this industry. Is it's at a little sexy moment where we actually have a lot that can be brought to a major challenge, which is feeding more people with less and less means to do it. So the technology moment is great. We just have to make sure that we don't miss the moment and that we don't, that we keep the innovation unleashed and going forward rather than trying to stop it or limit it. And that's probably our biggest risk, is that if we over-regulate at the beginning, I mean, let's pick artificial intelligence for a moment. You can scare off a lot of people with artificial intelligence in just a couple of seconds, right? So if we only take a protective approach to this, it's going to be very easy to over-regulate some industries. But if we get it right, then there's a lot of leverage that can be used for the future. But let's just think about potentially an autonomous machine. Most of the time, this autonomous machine is going to be on a private field. Yes, it will have to deal with a lot of challenges, but maybe less than other vehicles that would be running all through our cities and so on. Can we copy paste what is applicable to one type of vehicle to the other type of vehicle? I would suggest we can't, because if we do that, it's not going to be proportionate and it's probably not going to be appropriate. Should we have standards and approaches that go in all directions? Probably not either. So it's finding this right application of what can be reused while at the same time not over-regulating.
Okay, thank you very much, Jerome. We will
My pleasure.
continue also in the panel, and welcome to join there as well. We will now move on to Slavomir Sander. And Slavomir, he is the chair of the EU Robotics Topic Group Agricultural Robotics. He is also the managing director of Artificial Deutschland GmbH, with over 10 years of experience in automation, optimization, and robotics. He did his PhD on autonomous mobile systems with a special emphasis on mobile robots and flying drones. And since 2015, he is also coordinating the EU Robotics Topic Group Agricultural Robots together with my colleague Eldert van Henten. Slavomir, we work together on a strategic agenda. I would like to give the floor to you, and you can switch your camera on, and then you can start your presentation.
Thank you, Eric, for a nice introduction. And as you already said, we did the legwork for this document all together. It's my honor to present you the results and an introduction to our strategic agenda, European Robotics and Agri-Food Production, Opportunities and Challenges. And despite that we interviewed and gathered information from many people, their major contribution has been done by Kees Lokhorst, Eldert van Henten, Erik Bekeriet, Thilo Steckel, and myself. And I would like to emphasize that this is a joint collaboration between the agROBOfood network and the EU Robotics Topic Group Agriculture Robots. So over the next minutes, I would like to give you an outline of why we have this strategic agenda and how this strategic agenda that we have written in the past months, indeed in the past 10 months and published just a few weeks ago, how this is connected to the SRIDA, to the Strategic Research, Innovation and Deployment Agenda for EU Robotics and the new association ADRA. Later on, I will give you an introduction of our mission, the vision and use cases and use case themes, and also an introduction to the challenges that we have identified. And I would like to state also, or to quote a nice saying or a nice statement that robots create value by performing physical tasks that people cannot or should not or do not want to do. And a robot is a programmable machine capable of carrying out a physical task or a complex series of actions automatically. Now, as I introduced, I'm one of the coordinators of the agriculture robots topic group inside EU Robotics, and I would like to give you this umbrella how EU Robotics, Spark, SRIDA, and our strategic documents are connected together. EU Robotics, roughly 10 years old, is producing strategic research agendas that are then used by the Spark, which is a public-private partnership between EU Robotics and the European Commission to fund projects and to create impact here. And EU Robotics has guided in the past over 110 projects with a total funding roughly of 700 million euros, which is very important and also very good for us within the European Union. And agriculture is, alongside healthcare, maintenance and inspection of infrastructure and agile production, one of the 4 priority topic groups. And our strategic research agenda that we have created forms both the input to the strategic research agenda for Spark and the projects for the European Commission, as well as the road mapping of eRobotics 2.0 that is starting right now. And later on, I will show you how this is also connected to the ADRA. As I said just before, agri-food is one of the 4 prioritized application areas. An application area is an area where we focus on topics where the stimulation of innovation is likely to have a really greater impact and where it's really needed. So on the one hand side, it has a big market potential. On the other hand side, it is of high societal relevance, and it needs a seed or a push via funding, because to enable this huge potential that is possible by combining robotics, AI, and data. And agri-food stands here alongside with healthcare, with maintenance and inspection of infrastructure, as well as agile production. And we heard from Jerome a very good introduction why agri-food must be one of the priorities application areas, because we need to solve the challenges here. Now, eRobotics hosts a lot of topic groups, and we are one of them, the agriculture robots topics groups. Indeed, the current landscape contains roughly 30 different topic groups producing content for eRobotics for the European Commission. And we are one of the so-called market-driven domains. And alongside the market domains topic groups, we have cross-domain topic groups, like, for example, area robotics that can be used for both agricultural robots as well as industrial robotics or people transportation, if you want. We then have also a lot of technology-based topic groups, which are basically provide the enablers for cross-domains and market domains. And then we have all the societal topic groups as well, for example, taking care of the very important topic, education and training, also entrepreneurships or benchmarking and competitions. Now, given that we are a market-driven domain group, we created a strategic agenda called European Robotics in Agri-Food Production, Opportunities and Challenges, with the emphasis on robotics and to a lesser extent on AI and data. And our goal is to provide a vision and a mission on what robotics should contribute and how to facilitate transition to a more sustainable agri-food production. So on the right-hand side, you see the interaction between use cases, applications that with challenges and technologies. So use cases that we want to achieve need to be enabled by solving a couple of challenges, and challenges are solved by the appropriate technologies. Since we're a market-driven agriculture topic group, we are focusing on the use cases and the derivation of the challenges, whereas the other topic groups, for example, like the technology-driven ones, can provide the technologies that will enable the challenges or solve a couple of the challenges. Now, as I said before, our strategic document is not only used within eRobotics and Spark, but now we can use this to forward the content to agRA as well. agRA is a newly founded association. It's the AI Data and Robotics Association, just founded a couple of weeks ago. And this is a collaboration of the independent associations, Big Data, EuroAI, Claire, Alice, and eRobotics. So before we had eRobotics with the European Commission founding Spark public-private partnership. Now agRA will speak on behalf of everyone as an independent association, but all the other associations will stay independent as well. And agRA will provide the documents and the content towards the European Commission for Horizon Europe. Independent of that, eRobotics will be able to forward their own roadmap as well, and our strategic document is now used for the strategic research and innovation and deployment agenda for Horizon 2020, for the road mapping process within eRobotics, and we can now push this towards agRA to combine this with the view of AI and data and to form one combined vision and mission and view towards the European Commission. As I said, I was talking about mission and vision, and indeed we spent a lot of time to ensure every member and everyone who participate in the generation of these documents that we share the very same vision. And it is our vision that the future agri-food production networks will be flexible, they will be responsive and transparent. They will provide sufficient high quality and healthy products and services for everyone, really for everyone at reasonable costs while preserving resources, biodiversity, climate, environment, and cultural differences. And in this context, we refer to agri-food production to the delivery of products as well as associated services produced by or associated with the arable farming, with greenhouse production, livestock farming, or orchard fruit production, full field vegetable production, and as well as fish farming or fishing. And the delivery of the products and the services is embedded in a production or value chain, the so-called agri-food production network, which is defined as the ecosystem providing the agri-food products and covers the production, the data gathering, and the distribution and decision-making of all involved stakeholders and all steps of a production value chain. Now, given we have shaped this vision that future agri-food production networks will be flexible, responsive, and transparent, and provide healthy products and services for everyone at reasonable costs, we stated our mission to stimulate the development and integration of innovative robotic, AI, and data solutions that can successfully be used in those flexible, responsive, and transparent agri-food production networks. And our goal is to enable this by using the ecosystem approach to stimulate industry, to stimulate governments, as well as both producers and consumers to provide the opportunity to choose for AI. And this is important, not to force anyone, but to provide the opportunity to choose for AI and robotics-based solutions, because AI and robotics-based solutions are always a toolkit. And we will enable agri-food production networks that will be based on a proper balance between labor-based, service-based, and robotic data and AI-based solutions. Given that vision and mission statements, and that you see where we're coming from, the documents or the document aims to provide a contribution to the development of the SRIDA, of the AI, Data and Robotics Public-Private Partnership, and agRA. Second, a broad and coherent view of the needs and applications, and in particular the key challenges, given that we are a market-driven topic group, for the agri-food production in combination with data and AI. A 360-degree stakeholder view addressing technology, business, ecosystem development, human capital, everything. And we want this to be used as a basis for the vision, the alignment, and the development of programs, project groups, and consortia that aim to contribute to the development and the deployment of robotics, AI, data in the agri-food production network. Within our document, after roughly 10 months of interviewing different stakeholders and a lot of experts, we came up with 12 use case themes, where a use case theme is like a class of use cases. So for example, we do not directly describe harvesting of strawberries as a use case and harvesting of peppers, but in our case, this is complex handling and manipulation in primary production, for example. And for each of the 12 covered use case themes, we provided a description and a holistic view on the core functionality, the state of the art, the key challenges, a success matrix, and market sectors. And what you see on the right-hand side is are the 12 covered use case themes from robotics, AI, and data science for breeding, then complex handling and manipulation for primary production, as well as in post-harvesting. The next one would be realizing full autonomy of already mechanized tasks, followed by AI and robotics for livestock farming or precision agriculture. Cleaning is a very important use case theme, cleaning agri-food, as well as connectivity, distributed intelligence, and pervasive technology. Then we covered logistics and transport, ocean farming and agri-food, food preparation and presentation as well, and so-called as a placeholder, innovative, disruptively novel agri-food systems enabled by robotics. Because again, robotics is a toolbox, and there are a huge area of potentials that we currently cannot phrase, but some people will be able to create complete new system setups as well. Now, from these use case themes, we identified a couple of key challenges by asking experts from the relevant topics and from different domains. And we then categorized those challenges into the categories matching the digital innovation hubs, basically technology, ecosystem, business, training, and human capital development. And within each of these categories, we further divided the challenges into challenges specially related to agri-food and generative to cross-domain robotic developments. And what you see on the right-hand side, for example, within the challenge category technology, we have subcategories like world modeling, simulation, and benchmarking, or robot to X interaction, where X could be a human, an animal, a plant, soil, whatever. We have identified 24/7 level 5 cooperative systems. Here we took the notion a bit from automotive, where level 5 means that a car, for example, is able to drive under each circumstance in each environment, even in the case of errors and failures, in a fully autonomous way. Then we have perception in robotics, which is very important if you want to identify objects, plants, animals, or humans, despite any environmental conditions like sun, dust, or rain. We have multi-dimensional manipulation, as well in interactive design of trustful, safe, and ethical robot systems. In ecosystems, we have the sustainable pan-European agROBOfood network, and within the business, we identified a challenge push to market for agriculture robots and systems for support, education, and training, as well as specialized robots that can be used by seasonal unskilled labor. A very, very important part is the training and human capital development, which allows us connect people from agri-food with people from robotics analytics, so that we have cross-domain lifelong learning, and also to provide the infrastructure for practical training with access to robotics. And again, our goal is to focus on the use cases and the challenges, such that other ones can provide the technologies that will solve the challenges, that will enable the use cases. So who did all the work? As I said, the authors did all the legwork, writing everything together. Indeed, it's a cooperation between eRobotics, Topic Group Agriculture Robots, and the coordinators of the agROBOfood project. And we gathered a lot of feedback from our topic group members, from the members, coordinators, from the agROBOfood steering project group, industrial advisory board, from the project officers, from Rodin, Smart Agri Hubs, Iran ICT Agri, OpenDEI, ATI, and people representing organizations like SEMA, AAF, Animal Task Force, Manufacturing, High Tech, and many, many others, also many individual peoples from different domains like only robotics. I hope I was able to raise your interest in reading this document. If you want to read it, it's all open source. You can download it for free. There's a download link here, or you simply scan the QR code. And I hope you will be using these documents as we hopefully provide you enough information how we envision everything moving forward. And with these words, I would like to say thank you. Thank you to all the contributors. Thank you to everyone who made this document possible. And I finish with what I've basically started with. I am absolutely convinced that agri-food production networks will be flexible, responsive, transparent, providing sufficient high quality and healthy products and services for everyone at a reasonable cost, while preserving resources, biodiversity, climate, environment, and cultural differences. Thank you.
Okay, thank you very much, Slavomir. I have a few small questions. I think you did most of the work when you were writing this whole agenda. What was your biggest personal eye-opener? Why should people read this document?
That is a very good question. I believe people should realize that we are all on the same side, that we share the same vision. If you just see what Jerome presented just before with the vision and the mission of SEMA and the challenges we have, we are very, very close together already. And if we succeed in aligning vision, mission statements, and the challenges we need to solve over many groups and speak to one with one voice, also towards the European Commission, and also they see that we are all heading towards the same direction. And this is, I believe, the biggest strength that we can achieve. This is the biggest thing, that we combine all the skills, all the know-how, all the technological leaderships we have inside the European Union, and also stay competitive, both in industrial form or point of view, as well as in the technological leadership. And this is something where you can really share the view when reading the document.
And what was the moment that you really got enthusiastic about? Because I know you were becoming more and more enthusiastic when you were writing this document, because I joined you in this process. But what was the key moment when you thought, well, this is probably gold what we have?
Wow, I would say it started when we succeeded with shaping the vision and the mission. When we had so many people aligned on the same goal, then you know everything else. I mean, now you have all the experts, everyone wants to contribute, everyone wants to push forward, but the long-term goal where we want to end and how we want to approach there, this is set, this is shared. There's no politics, no fighting. There's everyone wants to work towards the same goal. And this, after identifying this, I realized this will be gold.
And when you compare it, what SEMA is doing, what can the robotics community contribute to the SEMA vision?
I believe we already share lots of the vision. So when I was listening to the presentation just beforehand, I was like, wow, should I take screenshots and put it immediately to my presentation to emphasize how this is already connected? I mean, it makes sense, because at the very end, we all move towards the same direction. And I believe SEMA has a very great view in their domain. And if this can be combined to an overall global vision, that will help so much, and it will improve the document. By the way, it's to everyone in the audience, if you realize a use case theme is missing, or a challenge is missing after reading the document, approach us. This is a living document and we can update it and therefore include more and more topics, etc.
Okay, good. Thank you very much, Slavomir.
You're welcome.
Yeah. We will now move to the panel discussion. We are even a little ahead of time, which is good, no problem. I would like to ask the panelists to come to the front when I name them. One of them is already there, and I will introduce you again, Slavomir, because not everyone jumped in at the same spot. So Slavomir is chairing the EU Robotics topic group on agricultural robotics. Slavomir is the managing director also of Artificial Deutschland GmbH with 10 years of experience in automation, optimization and robotics. He did his PhD in autonomous mobile systems with a special emphasis on mobile robots and flying drones. And since 2015, he is coordinating the EU Robotics topic group of agricultural robots together with Professor Eldert van Hensen from the Wageningen University and Research. So I also see Kees Lokhorst already popping up, so I will immediately go to him. Kees is the coordinator of the agROBOfood project, and he is also a senior researcher, smart farming and robotics, and has 35 years of experience in research that is focused on the use of ICT solutions to support operational decision making in several agricultural settings, especially in livestock production systems, and he is coordinating this agROBOfood project. Kees, do you also have a statement on robotics?
Yeah, I've sent it yesterday, and I don't know whether I still can remember. But being the coordinator of the agROBOfood project, I am convinced that robotics is the future. But I really hope that the pan-European network of digital innovation hubs will contribute to this future and will stimulate developments.
You even go a step further in your statement. You say that the future of robotics and agri-food production networks will become even brighter if the pan-European agROBOfood network of DIHs will become mature. So can you elaborate a little bit on that?
Well, we are an EU project, and that has an end. And we have 4 years, we are halfway now, and our main goal is building a pan-European network of digital innovation hubs. And these digital innovation hubs are there to support SMEs, and also these digital innovation hubs don't only support SMEs, but also end users. And setting up a network in Europe of all these different organizations with different culture is quite a job, but we are progressing, as also this event will show. And of course, we will not have a fully oiled robotic network, but part of the ambition is to make it sustainable. So it's also an invitation if people have thoughts how this network can really contribute also after the end of a project. So that's what we are aiming for, and that's meaning to build professionality in it, so that people and these digital innovation hubs also experience the strength of being part of a network.
Good, thank you. I will bring up the next candidate, which is Thilo Steckel. Thilo, can you switch your camera on so that we can see you?
Yes, I will.
Thilo works at the Claas company. He's also the chairman of the agROBOfood Industrial Advisory Board. He's very active in SEMA, so he is very much aligned in at both sides. He is working at the Claas E-Systems Advanced Engineering Group, has an agricultural engineering background. He is working in and coordinating research-oriented projects related to automation and AI, and acts in various research technology-related networks like agROBOfood and SEMA. So you are right in the middle, so which is very nice. And Thilo, what is your biggest hope for the agROBOfood project when it's a success for industry?
Yes, thank you very much, Eric, for your introduction, and hello together. Yes, I've been into robotics quite a while. That's almost 10 years, and it's still interesting to see daily advancements in robotics and AI and in data management. And in the beginning, I was quite critical to these solutions. How might they integrate into agriculture? Is this imaginable? And for me, it becomes more and more obvious that robotic systems are real problem solvers at the core. So because they are so cross technology relevant. And we started with discussing about technology, but this is so much more than just technology. So it might even be more important because technology is just a tool. So there are so many perspectives that are interesting. They are economic, they are environmental, and that are societal. And I think that's also from the other colleagues' statements. This can be seen, and this underpins our common vision that we all have on robotics. No matter where we come from, so we all come from we have very different backgrounds, but this vision that unites us, and this drove us and was very motivating for this document that Slavomir presented.
Okay, thank you very much, Thilo. We will discuss further in a few minutes. Let's move to Ivo Hostens. He is the technical director of SEMA. Dr. Ivo Hostens worked as a bioengineer with several years of experience in technical and legal consultancy. He joined SEMA in 2008 via Agoria, the Belgian Federation for Technological Industry. Since 2015, he works full-time for SEMA as technical director. His main focus lies with the new technologies. Since 2019, the function of Secretary General of EuroAgEng, the European Society of Agricultural and Biosystems Engineering, is also part of his duties. Ivo, your statements. Ivo, you can switch on your camera, I think. We cannot see your camera. Can you hear us, Ivo?
His camera was on for a while, but then it disappeared.
For a minute. Oh, sorry.
There's a message about a lack of bandwidth.
Okay. And can you talk, Ivo? Well, we will skip Ivo for a moment, and then we move to Reinhardt Schmidt. Reinhardt Schmidt is already in the meeting. Just jumped in. He is director of agROBOtics. Reinhardt studied informatics with a focus on AI and robotics at the University of Kaiserslautern and got a PhD from the University of Stuttgart in the area of cooperative autonomous mobile robots. At the Technical University of Munich, he was involved in the technology transfer and SME support projects, teaching and administrative tasks. Since February 2016, he is the Secretary General of agROBOtics. Reinhardt, you already sent me a statement. Do you have it in front of you, or shall I read it for you?
No, I can read and explain myself. Thank you, Eric, for the nice and kind introduction. Can you hear me?
Yes, very well.
Yes, okay, good. So, in my view, robotics technology can help to ensure and increase the quality of products. I think this is very important for the current situation, but at the same time contribute to sustainability and resource efficiency, which means we would have a very good benefit but we need cheaper systems. We need systems that are easier to install, to operate and maintain. And the full potential of these systems can only unfold in combination with the latest mechatronic design and other technologies such as AI, big data, and many, many more. So I think we have quite a good potential, but we need to make use out of things that are there in the research world, but not yet transferred to the market. And this is also why I kindly thank you for the invitation, because our association is exactly trying to get into this direction.
Yeah, and you are on top of all the robotic domains. And how do you personally look like the agri-food domain? What is it of value for the whole EU robotics?
I think this is one of the most interesting domains, because the food and agriculture has an immediate impact on everybody's life. Every person needs food. And as we have seen also recently discussing in German supermarkets, for example, meat production, they say we don't want to have this mass production anymore. We want to go for a higher quality, but also having a better life for animals. And the same holds true for our life in the classical agricultural domain, crop and all the vegetables, where you can make much more out of it when you pick fruits when the time is ripe, when you use fertilizers and other chemicals only when strictly needed in the dose, where actually needed for this individual very small area. And so this cannot be done without modern technology. And therefore, I think the agri-food domain can play two roles. One, placing new challenges to the scientific community, and also make use of what's already out there, maybe in completely different sectors. And we need to make a transfer both directly from the research side to the application domains, but also cross application domains.
Okay, thank you very much, Reinhardt. We will discuss further. Next one I would like to bring to the floor is Juha Heikkilä, and he is working at the EU DG Connect. And Dr. Juha Heikkilä is joined the European Commission in 1998 and was appointed the head of the Robotics and Artificial Intelligence Unit in the Directorate General of Communication Networks, Content and Technology in 2014. The Commission has been funding a multidisciplinary program on cognitive systems, robotics and AI since 2004, focusing on smart and flexible robots and artificial systems. In 2014, a public-private partnership in robotics was set up, bringing together all the key European stakeholders. In this partnership, the European Commission will invest up to 700 million via the Horizon 2020 framework between 2014 and 2020, and the unit is also in charge of developing and coordinating the Commission activities in artificial intelligence. So, Juha, you are also on top of the EU robotics domain, I think. What is your most important statement for the agricultural domain?
Thank you, Eric. Good morning, everyone, and thank you very much indeed for the invitation to speak at this event. I'm very glad to be part of this panel and contribute. So I think that's one of the things that I would like to highlight is that the EU is strong in advanced robotics. This is something that is not always understood. I think this community understands it better than some others. But we have a strong basis, and this strong basis we can build on. And as has already been pointed out, this new partnership that has just started, AI data and robotics, will contribute to that, will make it even stronger, and the necessary investment that we have on the EU side, and we will bring together with also, of course, investments from the member states and the private sector, they will make this field thrive and produce solutions to the challenges we face. And of course, agriculture is one of those areas where we face many challenges. These were already highlighted in the previous contributions that we saw. And all of these are known to this audience, so I don't need to talk about efficiency, improved sustainability, reduced environmental burden. Also, the question of labor shortages was mentioned. Maybe there's one thing that I would like to mention where robotics and modern technologies help. It's to give farmers more free time. This is not to be underestimated, because working in agriculture often means very long days, means few holidays and short holidays, depending, of course, on the type of production there is. So this technology, from our perspective in the European Commission, holds a lot of promise for this particular field. And some of the obvious points have already been mentioned, and also very subtle points in previous contributions and statements. So we do think this is a very important area. And as was pointed out already by Slavomir, in our funding activities, agriculture is indeed agri-food is one of the focus areas, was one of the focus areas in our Horizon 2020 funding. It will continue to be a very important area also going forward. We are, for example, setting up testing and experimentation facilities in agri-food to enable then to bridge the gap between the research results in the labs and the market, bringing these products and solutions closer to the markets and ultimately onto the market.
Okay, thank you very much. As Ivo is not able to manage to come to the front, I also would like to ask Jerome Bandry to come to join this panel. He is the Secretary General of SEMA. He is he's following an international career with a global industry leader of machinery and construction equipment, where he held several leadership positions with increasing responsibility over the 27 years. Jerome Bandry was appointed Secretary General of SEMA over 3 years ago to represent the interest of Europe's agricultural machinery industry. Jerome, can you switch your camera on? Yes, there you are.
I'm here.
And Ivo is not managing to put his camera on?
Well, you will remember my last priority was to make sure that we get internet all over the place, and I think his internet broke down, but I see that he was able to fix it.
I'm here.
Okay, Ivo. Ivo, so I already introduced you a bit. So you are the technical director of SEMA. Could you elaborate a little bit about your statement? Do you have it in front of you, or were you too busy with getting the connection right?
No, that was easily done, you know, engineers and their stuff. My statement is linked, of course, to the fact that we look at two things. One is of course, the more economic side. That's where Jerome looks at. Where is it economically going? Is it's going to be something that really going to pay off, etc., cost benefits? I'm looking more, of course, on how can we get the clear rules for getting things right, getting it on the market, that everybody's happy, that the liability rules are clear, etc. And therefore, my statement would be: will it be for having a bright future of robotics? It needs to be connected. It needs to be secure, globally aligned, because we produce for a global market. Lean on legislative procedures. It was already indicated by Jerome, by the way. Over regulation, we don't like it. You need to be lean on legislative procedures for maximum innovative freedom, but also with clear rules for every stakeholder in the chain, because you're talking about robots, not humans. So how do you communicate, etc. So that's why I had this statement.
Great, Ivo. Thank you very much. Okay, everyone can participate in this meeting by using the Slido, and I think Dimitra will show a slide with how the connection can be done. It's also in the chat. So in the chat, there's also a link to Slido with a hash, which you can use, and hopefully, you will also have questions to the panel. I will start with a few so that you can already think about one. And there's also another interesting feature in Slido, that's where you can like each other's questions. So the more likes a question has, the more it will go on top of my list, and you have a bigger chance that it will be heard. So here is a slide of Slido. So you can use your mobile telephone, just scan the QR code, and then there's the hash. If not, if you do not would like to use the QR code, you can also just type in slido.com with the hash 921288, and then you can already start asking questions. In the meantime, I will start with some questions I have in front of me. And I would like to start with a question to the SEMA. So let's try Ivo Hustens. Ivo, who is leading or should lead the way how we produce our food? So is it we make machines, you have the end user, who is making the biggest contribution, and you also have the consumer. How is this mechanism work, and what is the role of the industry?
I think industry is there to deliver on market demand, but of course, due to its knowledge and expertise, it can also help to show where it can be different. I think that's also where the link lies between industry and research, where sometimes research is even more independently and has less, I mean, I would say economic interests, and therefore could push even to more, better alternatives if possible. I think that's a bit where the links lie, the boundaries where we have to search, and I think that's also where we see that Europe is getting quite mature in getting all the right stakeholders around the table and giving them equal right of speech to go into the right direction, and develop the necessary regulations if appropriate to continue on the right path for agriculture.
Okay, thank you. I also have a question to the EU, so to Juha. So how is the EU looking at agri-food robotics?
I'm not quite sure I understand the question. How are we looking at it? I already stated that it is one of the areas that we have focused on based on the prioritization that we have received from the partnership, so the stakeholders in robotics. And this has been then reflected in our funding program. So we've had quite a number of projects, in fact, in agri-food. So in addition to this project, we also just started at the beginning of the year, we started pilots in agriculture, 3 pilots, and we had previously also projects running in different technologies in the application domain of agriculture. So those were projects that then developed the underlying technology for this area, in particular the application domain, the use case, if you like, was in the agricultural sector. Of course, also the sort of overall development of technology and the research funding that we use, I mean, that builds the kind of underlying technology that we need in agri-food, you need in agri-food as well. It was mentioned earlier that manipulation handling is one of the sort of key aspects, and this is, of course, an area that a lot of projects that we've funded over the years have focused on, and of course that also then feeds into the solutions that can be used in this particular area.
And if you compare the European role against to the other continents, how are we positioned?
So in terms of public funding, we are actually doing pretty well. So certainly the Spark partnership that we had with the robotics community from 2014 to 2020, the 700 million euros that the European Union invested in it, and the 2.1 billion euros that then the robotics industry invested in this technology. This was the biggest civilian robotics program in the world when it was set up. And it has in fact been the envy of many other regions. I've been to robotics conferences, international robotics conferences, where it's become quite clear that not just the sheer volume of funding we have provided, but also the way it has been channeled, collaborative projects which have brought together different disciplines, multidisciplinary research and innovation projects, and different teams from different parts of Europe, that this has been something which has not necessarily been possible in other regions, for example, to the same extent, for example, in the US. So certainly in terms of public funding, we are doing very well. Of course, we are not doing so well in terms of private funding, in particular in AI. So that's one area where we should do more, certainly, and we have also measures in place to stimulate the investment from the member states on the one hand, but also the private sector.
And how come? Do you have particular reasons pointed for that?
I think there are multiple reasons for that. Perhaps I think it's I would hesitate to speculate, but I think that one of the reasons behind this is perhaps a sort of certain risk averseness in Europe compared to some other regions. Access to finance is also something which is in some cases more difficult in Europe, or not so readily available as maybe in other regions. So I think that there is certain conservatism perhaps also in parts of the private sector which has contributed to this situation.
Okay. And I also could imagine that the ag-tech industry is very much SME oriented, which makes it also very difficult.
Yes, of course.
Okay, let's look at the Slido. Where probably we have first questions now, and I already saw a few votes. There's one. So do you think any robotic use cases are commercially viable yet, given the costs of robustness or solutions? Let's give this questions to Kees Lokhorst. He is the coordinator of the agROBOfood network. Kees, what do you think about these commercially available use cases in agriculture? Are they there already?
The simple answer is yes. And yes, the most prominent example is automatic milking in dairy cows. It's already every farmer, at least in Western Europe, investing in his new milking parlor is looking at a robotic automatic milking solution. And so it is accepted technology. Also, manure scrapers, feed pushers has been a silent revolution. And so that is accepted technology. Also in processing industry, you see quite some robots integrated, and people don't see it anymore as successes yet. Where you see most of the interactions and the noise, and then that's also around the open calls. That's on developing these robots for harvesting fruits, harvesting in arable farming, harvesting in glass houses, and also taking care of wheat, mechanical wheat reduction. So there, a lot of activity is going on by SMEs, by startups, and there you see a lot of energy in proposing solutions, also robotic solutions, but indeed they have to conquer the market and to convince also the end users that they will buy it.
There's another very nice question. I would like to send it to SEMA, first to Ivo, but also to Slavomir as one of the representative of Robotics in agri-food. Do you think there's enough collaboration or reuse of components between agricultural or robotic companies? Ivo.
I have to say, difficult question, which I not really can answer. Of course, when it comes to the use of components in general, we will always try to reuse in any case what is there on the shelf from other industries. Probably here it's meant specific components like software components, etc., architectures, etc. There are attempts to get some harmonization in these, and of course you have also a number of open source attempts to ensure that smaller companies can actually benefit from each other, and which is of course a good thing. But to what extent it is used, I'm not the expert.
No, you also do not have an idea how we are doing against the rest of the world?
In terms of deployment of robotic systems, you mean, or in terms
Yeah,
of
especially the collaboration, reuse of components.
I have no idea, I have to say.
Okay. Slavomir, could you elaborate a little bit on this?
So about the reuse of components, I mean, this is a very difficult question, how collaboration is already available between new emerging companies or existing ones. But what you see, I mean, there are a lot of startups emerging, not only within the European Union, but also outside from Israel or within the US. They also identified that this is a very big topic. And I believe what is enough collaboration? I believe the collaboration will start once we have some minimal standardization how components can be reused or can be shared. In particular, if we talk about software components, if we talk about data security or safety integration here, then this will also, let's say, stimulate this whole market because new companies will be able to focus on providing software pieces only that can be used by, let's say, machinery provider or technical industry and combine this with their know-how. I mean, this is why we have robotics, AI, and data. This is the whole story about it, because we need to combine these different domains, and we need to combine this all know-how from the sectors towards the next goal that we can move towards the next level.
Okay, thank you. Let's take a question from Rune. He stated that standardized power takeoff for tractors enabled multiple vendors to develop specialized equipment. What is the standardizations we need for agri-robots? Let's ask the industry first. So, which is Thilo Steckel?
Yes. I think this topic is comparable from traditional machines to autonomous systems. So there is standardization needed. But how important this standardization might be depends on the future development of autonomous systems. Do we see more specialized autonomous systems that can be seen as sort of isolated specific systems, so this problem can be solved inside this system with less standardization. But if you consider multiple purpose robots, like replace a tractor by an autonomous system that gives guidance and traction, then the same topic has to be discussed. But of course, these discussions about standardization in autonomous systems is of course behind the traditional systems. But on the other hand, it's always difficult to distinguish where do autonomous systems start to be autonomous systems. So I think we already discussed these topics, and they might find application in autonomous systems. So that might be a smooth change to a more autonomic-centric view.
Ivo, could you also elaborate a little bit on this question? How do you value the way vendors cooperate on these issues?
Yeah, I think it's as Thilo said, it's true. I mean, there's a lot of things that we, in any case, still have to develop when it comes to standardization on existing systems. And when you then have robotics, indeed, where you have fleets, we have specific control, centralized control, etc. That all needs to be standardized when it comes to the safety procedures, the security. That's why also I said if agri robots are connected, and we have the interoperability standards, etc. It will also have a much better take-up, because it will be easier for farmers to control everything and to do data management from their robots, etc. Send the decisions, get the data. And
how are we running in these discussions? Are we steaming up, or is it we should move much faster in this direction? What's your opinion?
We already, when it comes to interoperability, developments are ongoing, that's for sure. And industry is certainly committed. Once it's there, it will be rolled out. When it comes to, for instance, elements like cybersecurity, also first assessments are being done, and probably next year something will come out as guidelines from the Agricultural Industry Electronics Foundation. Of course, there's much more to be done still to ensure full data sharing within the chain. So that's an activity I think will be for the next 5 to 10 years to really get it fully out. Of course, it's already happening, but more proprietary solutions and of course interactions between and collaborations between big consortia. So it will be there, and there will be possibilities, but full, I think that's also the question that was there, like on the commercialization. Yeah, it will come, but currently the link between OEM and user, etc., will be quite strong because a lot of proprietary solutions will still need to be used and adapted to each other.
Yeah. Okay, let's also ask a question to Reinhardt. I also have one question on my list. Reinhardt, you are in the middle of all the robotic projects, but you also have some insights in agriculture and food. What do you think? How will we produce our food in 10 to 20 years? How would it look like? What kind of technologies do you have available for agri-food by then and deployed? You are muted. I think we cannot hear you.
Correct. So this is a very good question here. So I think on the shorter notice, we will have slight changes in the environment. I think especially agricultural community has the need for high investments to change to new things, and people need to be convinced. Maybe in the actual food production, the quick wins could be much faster than in the agricultural side. However, I see high potential, especially for the, let's say, more on the, for example, vegetable side. When the technology is there, for example, to do better picking and so on, then there might be markets for getting higher automation. At the same time, you see more and more structured environments for food production, glass houses, even in areas, rural areas where typically things were on the field. Now things are put into structured environments, and this helps, of course, the automation, because you don't have to deal with too many weather, weed, and other things. They are much better under control. So I think when these things come together, maybe we face even a faster take-up of robotics technology because the environment also changes.
Thank you very much. Interesting. So let's elaborate this also a little bit towards Thilo. So a more structured environment. And if I read your statement, it also should contribute to the environment and societal aspects. Is it possible to combine this?
Yes.
If you also think about biodiversity, these kind of things, are we able to do this?
Yes, I'm very, very optimistic in this way. If you consider current machines and you compare them with your vision on robotics, so we have new sensors, we have new decision support, we have new algorithms that can relieve the operators and the drivers of the machines from these dirty, dull, and dangerous tasks. I expect much more efficiency from these machines. So, like in dairy farming, where you consider every animal as an individual. So we're getting closer to consider plants as individuals. It might not make sense to get to a unique plant. I don't know. The future will show. But in the orchards, it already happens, and I think that's a bright future. You can consider or reflect all different properties of different areas. So you can optimize your processes to the very small local areas, and this has benefits in every dimension. And I think to add from Reinhardt, Reinhardt, you mentioned about structured environments. I think there's also a high potential at the opposite side. Working in unstructured environments, because the technologies will allow to consider all these special properties in these small micro spots. So come up to spot farming. So robotic systems might allow us or help us to move towards spot farming, and yes, and then do the right things in the right place at the right time. And I think there's a lot of potential. So the economic factors are still not very much settled. We have to further explore that, but I think there's a lot of important and interesting things coming up.
Okay, let's see what Slido brings on the screen. I thought there was also a very interesting question on the European robotics side. I don't see it yet. Okay, let's. I have another question. So we probably robotics will demonstrate that we will produce differently. And let's move a little bit in the specific stakeholders. So if we look at we can look at the value chain or the rural impact, and also at the farmer level. So Ivo, what do you think in the future will be different at the farmer level? And SEMA already spoke out that at the moment 1/3 of the farm managers is over 65, and the uptake is poor. So how are we going to boost this, and what is important for the farm? Why do not all those farmers use robotic technologies?
I think it's a pure matter of cost and apparently also complexity. You need to be an expert to use also software systems nowadays. So as long as it's not really plug and play, unless of course you go for one dedicated solution. Farmers want to have the freedom. Sometimes they want to use different brands. So brand independent decision-making tools and also robotic systems that can be easily plug and play connected to that system will be key. But it will be, I think it's an inevitable route that we have to take, not just because we will have a lack of labor cost, but just because of the complexity of farming, which will go up due to the new targets we have, not only on pesticides, fertilizer, but also biodiversity, etc. So using other crops, using different crop rotations, crop diversification, you name it, it all makes farming much more complex. And so it will be coming. And that's what I see for the future, that farming will in any case become, for farmers will probably become just managers of fleets and managers of data.
But I could also think about you can solve the costs by using other types of business modeling, and also based on the expertise, I would say, make your dashboard and technologies more convenient for the farmer. What is your answer on those two? So do it differently. Because my smartphone is also very complex, and even my mother can play with it.
Yes, but that's the plug and play that you need. It's the complexities in the back end, not in the front end. But as long as you have proprietary solution, it works very nice for that one solution. Once you want to combine these two, you need to be an engineer and a software engineer to make it work. And that's, of course, something we need to solve.
Yeah, okay. So it's the job on the on the engineers. So it's not a job for the farmer, or will it be also a job for the farmer to connect all these kind of systems?
No, this is actually for industry to come up to, as we say, like interoperability is one of the main key elements to ensure that this plug and play can work. Yeah. To start with the data, of course, as industry, we have a legacy there because we already allow that different brands connect to each other, like tractor and implement, not only for message transfer, but even for decision transfer, for task transfer, where an implement can say, you know, I'm running automatically. I need this speed, I need this power of the PTO, and this can automatically go to the tractor, and it provides that power in its own capacities. So the tractor will take the message, will take the decision, and will answer appropriately.
So take this to
And
your
that,
dream
of course,
in 20 years. How will the farmer use his robots? How would it look like?
I think the farmer will be taking his coffee, and in the morning he will check what tasks are still there to be done, because his decision support system makes some suggestions based on the weather forecasts that he gets, etc. He probably also gets the assist of how economically beneficial is it in this period of the year what to plant. And based on that, he will probably ask his system to make a plan for the growing season. And then a lot of things will be automatically done, and just tell the farmer, I think we need your decision now. Press the button, yes, if I can proceed in planting the seeds or in preparing the land, etc.
That's a very nice dream. Yeah, perfect. Before that, I also would like to talk to Thilo, because one of the issues SEMA also mentions that the uptake is very poor. And what are best practices? What could enhance the uptake of these complex systems? How can we convince the farmer?
Yes, so just to continue the idea, this is I think it's reducing complexity in the systems. This is an everyday job, reducing complexity. This is not only since we are talking robots. This started much earlier. So that's always the same process. If we have a new technology, complexity, the perceived complexity increases, and we have to hide this complexity and make these systems improve the usability of these systems. But I think there are two things that might be more important, and one thing is the economical impact or economical unknowns that we currently have, and another aspect is so what Ivo says. So my schedule, my daily schedule will change. So, and if my schedule changes, my competences, I need different competencies to execute these tasks. So I'm more towards decision making and less about repetitive tasks. So we have currently a workshop series with teachers from agriculture and agricultural technology education, basic education. And in these workshops, it becomes obvious that this is a key issue. And so we have to start with to integrate these topics into education. So if we don't do this, I think this might be one of the major blocks for market entry, unless there's a completely different business model, and that's another issue. Talking about business models, how will farming look like in the future? But I think on the other hand, it does not change the structure too much, because we still have family-operated farms, we have large enterprises, and yes, and these robots, they scale different. They don't scale in working width, but they scale in number of robots. So these smaller farms can keep the pace, but have to work towards different competencies, and the whole community needs to support the farmers and also the contractors, the agricultural contractors. Yes.
So I have one question to Jua. How is the Slavko asks, how is the EU policy about stimulating private farmers in order to initiate agro-robotics usage at their farms? Is there a stimulation package for them?
So we have a number of measures in place, and indeed the digital innovation hubs are an important instrument in this regard, because they will enable farmers, like other uses of digital technologies, AI, robotics, you name it, to go and see how technology works, get advice on how to use the technology, how to embed it in their operations, in their business models. So we do think that these, because they are also regionally based, so they serve the local regional community, and they are numerous. So they will help, of course, the farmers to also the farmers in those areas where it's one of the main industries to familiarize themselves with the technology and to get sort of suggestions for solutions, get ideas, and to see how it works in practice. So this is one of the key objectives, in fact, of the digital innovation hubs in general, and of course also in the area of agriculture, to make it more readily available. We also have other measures in place which we think will gradually support this goal. So one of them is, of course, we are building this AI on demand platform, so making available technology which is out there and building services on top of it, so that it comes readily available and easily exploitable. That's part of the goal. And of course, I mean, some of the challenges in this respect in agriculture are sector specific. Cost was already mentioned by one of the speakers earlier today. That is, of course, one of the questions. Robustness, of course, is another thing. I mean, those who work in farms know that things have to be very robust, almost military-grade robustness, and things tend to break down quickly. And of course, there is perhaps some skepticism also towards technology because of the sort of perceived lack of robustness. And this is something, of course, where the community will have to, the research and innovation community will have to work harder to make it robust. Though on the other hand, I've been very pleased to see how well on the ball, so to speak, the farming community is about this technology and its potential. It is actually well informed in many places, more so than some other communities, about the benefits that this technology could bring. This is something I've seen when I've spoken at these events or when I've talked to members of this community, and it's encouraging to see how this technology is perceived and how the benefits and the advantages it could bring are actually understood.
Okay, one question to Reinhardt. Reinhardt, what do you see in other domains what could be potentially interesting for the agri-food domain when it comes to uptake when it comes to uptake specifically?
I think in many cases, at the moment, there are also standardization and other efforts in the service robotics environment. And as service robotics has a lot to do with manipulation of everyday objects, also not necessarily the industry rigid aluminum or other metal parts. I think there is a lot of potential transfer to the agri-food environment. But the same holds true for the increased need of cloud robotics solutions, which are, of course, considering all the cybersecurity aspects, fleet management, and many other things. So the community is coming from completely different direction, such as service robotics for hospitals, or the classical AGVs in larger quantity in factories. They have a lot of technology already developed, which could be used and adapted to agri-food. Of course, here we have specific requirements. It's a difference between indoor and outdoor things. But the outdoor environment is also well covered by the maintenance and inspection groups, because they are aiming, for example, to look at pipelines and other infrastructure, streets, bridges, and so on, which are outdoor, where you have also different visual conditions, not an artificial uniform light, but really weather and season-dependent changes in the environment. So here I see a lot of collaboration possibilities, and therefore it's pretty much important that the communities talk to each other, share best practice, and find the common ground for transfer.
Okay, thank you very much. One question to Kees Lokhorst. What is the role of the European AgTech ecosystem in the rest of the world What are our strong points and our burdens?
That's a difficult question of the agtech industry. In itself, it's quite strong already, showing already in this discussion with representatives from the SEMA and IF. I would like to elaborate a bit more on what can be expected from the agROBOfood project, because building such a pan-European network of digital innovation hubs, it's empowering, I think, the SMEs and the startups. And if we look to the different open calls we have had organized, so half of our budget is for open calls, and they are dedicated to these SMEs and to these startups, and they were really interested in joining and working on robotic solutions and having the discussions on the strategic agenda together with the Industrial Advisory Board. I see that empowering this community of startups and SMEs together with the let's call them the bigger companies organized within IIF and SEMA, that is also a gap to bridge. And if they also come together, but because these startups, it's becoming able because we see these developments in technology and having remote contact, so IoT, AI, for them it's really quite easy to start an idea and to start a company, but really to get to products, to solutions that are beneficial for farmers or for other stakeholders, that's a big challenge. And the connectivity between these bigger and smaller companies, that's really an issue to improve.
Okay. One other question I would like to ask to Slavomir, and then we will do a round as a closing, but I will come back to that later. Slavomir, also envisioning the future in 10 to 20 years, if you look to the rural environment, most of the rural environment is agricultural based. So how will it look like with all the robots? What is your dream?
I really hope, and I guess we have a high chance achieving this, that we will see an environment that is highly biodiverse, that is semi-automated or fully automated, where we have humans working alongside in collaboration with robots, and also, let's say, not in collaboration with animals, but where also animals are having a different role that we have it today, not packed and stacked as we have it today, but let's say have a better living as well. I believe that given that robotics is a toolbox, and new farmers that are now emerging are basically also digital natives, and they will adopt robotic solutions much faster. And given that we will have a lot of data available and AI-based, let's say, solutions or AI-based potentials that the farmers can use, we will be able to create completely new setups for crops or crop rotations, or even a mixture of different crops, that we will take into account not only the effect of arable farming, for example, but also let's take bees into account. Let's take the climate into account. How should we now create and make setups of the fields such that we can not only produce much healthier food, but reduce our footprint on the environment at the very same time, ensure that animals that live alongside are also healthier and have a better living.
Okay, thank you very much. So I would like to do a final round, and then we close the session. I think we already were ahead of time, and I think most of the things are said. So I would like to do a round by each of you to come up with things perhaps not bring forward and you really would like to tell us as the agROBOfood network, but also tell to each other how can we improve this agri-food robotics perspective, also from the consumer environmental impact. Basically what's on your heart, what you would like to tell. So I would like to start with Kees.
Well, try to keep it short. What I really hope is that people also become aware that redesign and design of production networks and production systems is also quite an important one, and that also in that design there is also a good observation of what organizations really want to do, because they have the choice either to do the work themselves, either to work with external labor, or to use specialists and service providers, or to make the choice to go for fully automation or robotics. But it's a choice and an organization issue.
Okay, Slavomir.
I believe if you look at the next generation or the upcoming generations, I mean, they want to change the world on their own, like every generation wants. And we can give them robotic solutions at hand so they can change the world, the climate in a positive fashion, and the whole agriculture. If you look at the startups that emerge from US or Israel, or also from Germany, they are all young people that push into the market, because agriculture is becoming cool again from their point of view. It was always cool and necessary, but from the new digital natives and the new techie guys, it's really something they can tell their children, I change the world towards a better place. And we have now the chance to give them all the potential tools, decision tools or decision helpers, also the ecosystem and the digital innovation hubs and everything that is around, to give them a head and say, now you can really move forward. Now you can change the world. You can make it more sustainable. And I'm really looking forward to this, and I'm convinced this will happen.
Thank you. Ivo?
Eric. Yeah, from SEMA side, of course, we definitely believe that new technologies will deliver, and we do hope that we get a real green revolution, not the one we had in the 50s, where we had massive production, of course, increase, but at the cost of, and that we can have an agriculture that, due to these new technologies, can actually be at the forefront for delivering also on aspects like countering climate change. Increasing our biodiversity, make it more resistant. I hope that this can be done indeed with both big and small companies. And in that sense, I would like to add to what Kees has indicated on the open calls. We have an SME group, and we do see there that there is a lot of interest in such open calls for them, with less administration, but with the necessary funding and the possibility to connect to the rest of Europe for finding suitable solutions and partnerships. That is key, and I think we should really go further on that direction. Of course, I think there is a lot still that needs to be done in general for new technologies, and in particular also, of course, for robotics, in order to fully commercialize it, that it can be used all over Europe. And we really will commit to that together with, of course, all the partners in the agROBOfood consortium.
Okay, Reinhardt?
Yeah, maybe a different angle which was not yet addressed. So it's a combination between local production and food actual industry. What triggered my thoughts was in some report in the radio, where they said in some areas only the let's say first class food is sold in the supermarket, and up to 20% or with some vegetables or fruit even more is considered as waste, while the food industry buys things from China or from elsewhere in the world because it's cheaper. So I think keeping the things which are grown here and just putting them away as waste, this is really something which we actually should avoid, and making it with an automated way competitive, or also looking into the policy side, how to keep what has been produced here and bring it back to the individual food production in Europe. That would be a great step forward. And when we are talking about 20%, you can imagine how much economic value there is behind.
Yeah, okay. Yeah, thank you. Thilo.
Yes. So when I started 10 years ago in Robotics in the agricultural robotics topic group, we were a very tiny plant, the agriculture. So, and it's amazing, it's very amazing for me to see how agriculture developed. Agriculture came on the stage together with innovative technologies, and this is a very interesting thing to see. And it is especially interesting for me to see the behavior of the small and medium enterprises. So I expect from the SME, I expect very soon noticeable developments that can be seen. So this is one of my experiences while supporting agROBOfood. But there's also an issue because the large companies behave different than the SMEs. There's a lot of reasons for that, and it is important, I think, to exchange between larger and smaller companies because they have different knowledge that make something new if we join these forces. And a last thing, I noticed that there is a lot of interesting networks coming up, like agROBOfood. That's a very nice. If it's close to experimental research, it's very nice. So we have to be very careful in each of our countries that these networks touch the ground, so that we really don't end up at the engineers and at the scientists, but end up at the farmers. So we need to take a lot of effort to get there and to improve things. That's it from my side.
Okay, thank you very much. Jua.
So I have two comments at two very different levels. Firstly, this area shows in a very concrete way how it contributes to two of the main goals of the European Union, the Green Deal on the one hand and the digital decade. It all comes together in this field in a very concrete manner. So you are at the heart of, in a way, the kind of activities that contribute to the goals of the Union. So I think this is quite intriguing, this is fascinating, and you have a big role to play there. And then at a different level, projects like agROBOfood are very important then in explaining this technology, in informing the community of its possibilities, what it can and cannot do. Outside the European Commission, we try to put in place the funding that is required for it for our part, next to, of course, other funding sources, but for our part, it's quite important, and we focus on that, and the framework, so that this technology can be deployed and used in safety and with confidence. And then you have a role then in bringing this technology and making its potential known and contributing to its broader use, and thereby then contributing to these higher level goals that I mentioned at the beginning. Thank you.
Okay, Jerome, last words are up to you.
Thank you. Thanks for allowing me to step in again. Fascinating debate. Thanks and great exchange. Maybe I'll add three perspectives and putting three perspectives of things that have been already said. As was stressed by the Executive Vice President Timmermans, I mean, the Green Deal will not be achieved without technology. If we don't leverage technology, we're not going to get there. But as manufacturers, we should never forget that we're here to create value. If we don't demonstrate the value to the end users of what digitalization and what automation can bring, we may end up with solutions looking for a problem. And We don't want that. I mean, we need every time to create value for the users. So that's the first perspective. The second one, and the gentleman from the Commission mentioned it, this is a life changer for the farmers. It is completely changing the conditions that they have to face in order to produce food. And we should not, I mean, you can't put a price tag to this, but we should not underestimate that some folks don't have to wake up at 5 in the morning to milk the cows, or that a lot of other things will just be happening on its own. And when they get into the tractor, their day is basically over because the machine knows what to do, right? So more and more, this is going to change lives. This is the second dimension. Third dimension, let's not underestimate the customer acceptance part. And I think it was stressed in one of the questions. I mean, indeed, we agree with automation in a number of activities in our life, transportation, health, where it's a no-brainer. But when it comes to food, I'm not sure that customers are already 100% ready for full automation of farms. So how do we work on that, and how do we make that more explicit and understandable and agreed upon by customers should not also be underestimated. Thank you.
Well, there is an ethics workshop tomorrow morning. Perhaps you could join that one as well about these kind of issues. But nevertheless, thank you all very much for contributing to the panel, also for the whole audience. You still sticked with over 50 people, so very nice that you also brought in the questions. Yeah, stay connected to the agROBOfood. It's also possible to sign up as a company and as a digital innovation hub. If you did not do that yet, and you would like to be more involved, you can also subscribe to the newsletter there. So just have a look at the website if you would like to do more in the agROBOfood project. To the panelists, thank you very much. Hope to see you a lot more and interact with our network a lot more. Thank you very much for all the good words, and yeah, let's try to make a very dreaming, positive, yeah, agricultural with a lot of robots, because I certainly think that it can change the way how we produce food, and it can contribute to a much better environment, biodiversity, also a changing role of the farmer, not 24/7 awake, but have the technology around him to support him in his daily operation. That would be wonderful. Thank you very much, and I hope to see you in other sessions as well.
Thank you.
Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you.